Okay, I'm going to start drawing a power switch for my new Avenger. I'm going to do a switch similar to what I used previously, but this time I'm not going to make it out of cardboard. I'm going to use a 3D printed body, so you better draw that up. I'm not entirely sure where it's going to go in the robot, but you might as well draw it first and then figure out where it will fit later. So the first thing I am going to do when I draw my new switch is create a new assembly. I'm going to drop in some content parts which I know I use. So we need a screw to go through to turn the switch on and off. There's a screw. There we go, there's a nice screw. I suppose I need some nuts. Well, I need some nuts in the model. We want 2 nuts. Just for the fun of it, these look like steel nuts at the moment. I want brass nuts. We'll just highlight those material property. So this will change the appearance, different colours. Oh, there's brass. There we go. That looks like brass. Dirty brass anyway. Okay, so there's my 2 nuts and my screw. And we'll get some ring connectors. So that's what my switch is made out of. So it's a nut. I can almost put it together at the moment. We'll insert my nut onto my ring connector. Pop. And this one inserted onto the ring connector. Pop. So when I made my switches, I soldered my nuts onto my ring connectors. And that was hot glued onto a bit of cardboard through the middle, so when you took the screw out, the switch turned off. But I want to do a 3D printed body so I can actually bolt the thing to the robot. So what I'm going to do with this little assembly is take a few measurements for the ring connectors off it, because I don't actually have any ring connectors anymore. I used all mine. So I'll take some dimensions off the ring connectors and then put them into a new part. So we'll create a new part. What I need to do here is create new parameters. Here we go. So we open the parameters, and what I'm going to do is I'm going to create a new add numeric parameter down the bottom here, create some new user parameter, and I'm just going to put in some of the dimensions for the ring connectors and screw sizes and stuff, that way I can keep track of it all. Okay, so I've just added in a few more parameters, which are dimensions I think will be useful. I know the length of the screw, the height of the nuts. There's a few of the ring connector dimensions which I'll have to measure. So, excuse me while I do that. Okay, now I'm going to add in a few dimensions which are going to be useful on the Avenger assembly and probably other robots' assemblies, because I might use this switch in lots of different robots, so it'll be handy if I have some mounting bolt dimensions. Okay, so I've added in the size of the mounting screw and the space between it lengthwise and the space between it widthwise. I've gone for 25mm spacing at the moment, but I can change that later. So now I can actually start doing some drawing. And so we'll go in this little drop down box at the side, has a list of all the parameters. So there are all the parameters we just put up in that box. We can select the brass screw size, and we'll plus 2mm for clearance. So brass screw size plus 2. There we go, 6.8mm hole. Select parameter, mounting screw size plus 2 for clearance. There we go. And we'll do mounting screw space lengthwise, and the parameter for mounting screw space widthwise. Finish. So that's what the top of my screw, my on-off switch would look like. And I'm actually, instead of extruding straight off that, I'm going to do another sketch straight away. Just because I can. This is how I like to draw. I like to do a couple of sketches first before I do a projection, just to make sure that I get everything right. What I've just drawn in construction lines is basically what the dimensions I took off the ring connectors. So it's the outside diameter of the plastic cover, the center line of the wire to the base, and the length of the plastic cover to the center line of the wire. These are things that I want to work around because I want to make sure there's holes around the ring connectors so they fit in nicely into the switch before I hot glue them in. So I've taken all these dimensions off. We might make the whole block of the switch higher than the top of the ring connector. That way, if something presses against the bottom of the switch inside the robot, like if a battery breaks loose and whacks into the bottom of the switch, we won't whack into the ring connector, we'll whack into the actual body. That way nothing would jolt loose or break loose. So if we make that the whole switch height, oh, that's 19, so if we make it 20, I know the ring connector only is going to fit in there. Yeah, I've also realised I probably need another parameter off those ring connectors, the outside of it, so I know it fits in snug. Alright, so that's what that looks like, top and bottom. So it's basically just the ring connectors in a block, nicely protected. What I probably should do on this one is put a little, I don't know what to call it, little cover on the top that goes around the outside of the brass head nut. That way the brass head of the nut, because it'll be live when it's turned on, we don't want it touching the chassis. So we better extrude up a little cover to go around it. So that's that. That's what a little switch would look like, a little 3D printed bit. A lot of plastic in there. We could probably lighten it, but it doesn't matter. Wonder how much it weighs. Go to eye properties, physical, we'll change the material to, let's go nylon. Yeah, we'll go nylon. 24 grams. Apply. Oh, let's change white. Sexy white nylon. Yeah, that's kind of a disturbing thing to say. So, actually, when I draw this on the robot, I'm going to have to know the outside of that. So we'll go back to the sketch. Edit sketch. We'll add a dimension to the outside. It chucks a wobbly because that will make the sketch over constrained. I say accept anyway because fuck you, computer. Tells me the outside diameter of that one is 15 mil. Okay, so if we look in parameters right now, if we scroll down, it's added in a new column here called reference parameters, which is that 15mm dimension, which we're not allowed to edit. So if we right click on that dimension, dimension properties, the name of that dimension is D35. Now we're going to change that to switch something. I don't know what to call this. Brass screw protector, wrong spelling, it'll do. Brass screw protector OD, the outside diameter of the brass screw connector, protector, whatever. Okay, apply, done, finish sketch. Yeah, if we look in parameters again, yeah, our reference parameter is now brass screw protector OD. We can probably change the name there, but we want also to click on and change the dimension properties and change it there. But I know that I want to use that parameter in the other dimension, in the other models, so we better name that one and keep it. And the reason why I do that is because if I decide that 8mm head on my brass screw is too freaking small, then it's not going to work. And it needs to, actually should be 9mm if we change that. Done. We update, and that gets bigger. The reference dimension increases to 16 mils, and that 16mm will be transferred into other models and hole sizes will be automatically updated. Change back to 8 because I know it's 8 because I've got the thing sitting in front of me. Yeah, that's what my little switch would look like. We'll save that. I have a nice little common parts folder which has all sorts of wheels and batteries and valves and all sorts of junk. We'll save that in there. Okay, that's what my power switch would look like. So basically, yeah, nuts soldered onto ring connectors. Then you put them in there, put the screw in, run some hot glue over there. It helps if you have the screw through before you hot glue it, that way you know the threads are going to line up and everything will sit right. And then that would bolt into the robot. Yeah, that's all sexy. So yeah, that's how I'm going to do my brass switch, my on-off switch for my robot.